So if we talk about the acceleration, so what is acceleration? Rate of change of velocity. Again, you can categorize into 4 types. One is uniform acceleration, non-uniform, then your average, and then instantaneous, right? And what is this average? Your average acceleration is defined as delta V by delta T, right? Okay. And this instantaneous is nothing but when your delta T tends to 0, delta V by delta T, and it will be written as dV by dt. Is it clear? Right? Let us see from the diagram. Say we have, say, velocity versus time graph. Again, it is given something like this. So velocity is changing like this. And let us take 2 points A and B. We will do the same working that we have done for the your
Average
velocity. Yes, average velocity. So let us say here the velocity is V1 and here the velocity is V2, right? And this is T1 and this is T2. Again, you will draw a secant, right? And complete the right angle triangle, and say this length will be delta T, and that will be your delta V, right? And tangent of this will be delta V by delta T. Is it clear? So you can say this is nothing but the tangent of the angle, right? Okay. So that again you will get the similar type of question. Now this is change in velocity. So if I give you a question, say a particle is moving in a circular path, right? Okay. So the particle is it is having a uniform circular motion. So what is a uniform circular motion? Its speed is not changing. It is accelerating. There is an acceleration towards the center, right?
Yes, yes.
Okay, so let us say it has a speed v. So when the particle is at this particular point and this angle is 90, its speed is same as v, right? Okay, so can you tell me, and the radius is r, so what is the average velocity, so average acceleration of the particle? Can you find that? Find average acceleration of the particle as it moves from A to B. So this is A and this is B, right? You know the speed, you know the distance, right? Covered by the particles. You can find the time, right? So time will be distance, which will be 1/4 of the circumference, right? So your final velocity is this, right? So this is your V2, let us say. So we have to find delta V. Delta V is what? It is V2 minus V1, right? And this will be your minus of V1. Is it clear? So the resultant of the sum, this difference will be this, right? V2 minus V1, which will be what? Root 2V, right? So the magnitude of delta V will be root 2V. So your average acceleration will be root 2V upon pi r into 2V square. Got it? 2 root 2 V square by pi r. Clear? Right. So when a particle is having a uniform acceleration, so what are the equation of motions? Can you tell me? Suppose v is your initial velocity, u is your initial velocity, v is final velocity, t is time, a is acceleration, and s. Now these equations are vector equations. So you can write it like this: vector v is equals to vector u times vector a times t, displacement ut half at square, and you can write this equation as v dot v equals to u dot u plus 2 a dot s. Got it? And there is another equation which is known as your average velocity, that is u plus v by 2, right? And the displacement in the nth second, that will be u plus a by 2 plus 2 a dot s. Got it? And there is another equation which is known as your average velocity, that is u plus v by 2, right? And the displacement in the nth second, that will be u plus a by 2 plus 2 a dot s. That will be u plus a by 2 2n minus 1, right? So you have to remember all these equations, right? Okay. So let us do some questions. So that we have already done. You can do this as a homework, right? So I've done this. Okay. A driver takes 0.2 seconds to apply brakes after he sees the need for it, right? This is called the reaction time of the driver. If he's driving the car at a speed of 54 km per hour and the brakes causes a deceleration of 6 meter per second square, find the distance traveled by the car after he sees the need to put the brakes on, right? So there is a car which is going with a speed of 54 km per hour and the reaction time of the driver is 0.2 second. What does it mean? Your car will keeps on moving for that much time with the same velocity. And after 0.2 second, the brakes are applied, right? And then there will be deceleration. So you can see your car moves from this to this distance with the speed with the for time 0.2 seconds, right? And beyond that, you have a deceleration of 6 meter per second square, right? So you have to find this total distance. So that is known as the stopping distance, right? So can you calculate the value? You have to multiply with 5 by 18, right? 54 into 5 by 18. So it comes out to be 15 meter per second, right? So what is this distance? Let us say this is x1 and this is x2, right? So what is x1? Uniform velocity we have, right? Speed into time. So 15 into 0.2. Okay, so it comes out to be 3 meter, right? So now you have to calculate what is x2. So at this particular mark, the speed of the car was 15 meter per second, right? At this point, the velocity is 0, right? So final velocity is 0, initial velocity is 15, and the deceleration is 6. So we can apply the last equation, v square equals to u square plus 2as, right? And we can find this x2. So we can say final velocity v square equals to u square plus 2as. This is 0, u is 15 plus 2. Acceleration is opposite to velocity, so we will take it as negative, right? X2. So x2 comes out to be 225 upon 12, right? Or you can say it will be 4, and that is 75, and this comes out to be 135, right? Sorry, 38, 3075, right? 18.75. So the total distance will be 21.75 meter. Is it clear?